video, we'll be getting online with my Foenix F256 Jr, which is back here. I'm not using a featherboard. I'm not using TCP/IP. This is going to be simply using one of these Wi-Fi modems, which have been around for a while. Contrast to, of course, the, I don't know if I call it ubiquitous, but the original Hayes Smart Modem. Of course, this is a 2400. I have a 1200 too, which was my original. I got this from a friend recently. The 1200 was a big deal when it baud rates jumped from 300 to 1200. My dad brought me a 1200 home from work, borrowed it, and I guess I'm still borrowing it 30 years later. But so today we're going to cover how to hook this up to the Junior, how to configure it, if you know, serial send and receive, how to write a basic program to act as a terminal emulator, 5-line, or should I say this, 5-line, a 5-line terminal emulator. And we'll talk just briefly about what was happening in 1978 and this article in Byte magazine, which reflects back to the original CBBS system developed by Christensen and one of his colleagues. I won't scroll through it right now. There's an article in here which was essentially the first BBS, Hobbyist Computerized Bulletin Board. And this is on page 150 of the 1978 November issue of Byte magazine. And you can buy this on eBay, as I did. And it's a very interesting article, and it talks quite a bit about what they were thinking, how they did it. It was using an Intel 8080 based MSI machine, which you know, was one of the early, I guess, 8-bit machines that people bought as a hobbyist that they later configured with a bunch of cards. But that was kind of the first BBS. We're going to actually get online with this modem that I showed you previously to this original bulletin board, which is still online. So you'll see what that looks like. I'm just going to kind of reconfigure things here, and we'll get started. Okay, we'll start by talking about the hardware. As I said, this is a C256 Jr, which is the development board. There's a predecessor to the F256 Jr, which most people have. There are very few people have the C256, but it's the same machine. Essentially, it's got a few differences as covered in a prior video. You can look for that in the link below. I'm going to turn this on, reach over here, power switch here, and you'll see just quickly that I've got a wired serial port, which is just a 3-wire connection to well, a spot on the board, which I'll provide a close-up of, which is where it plugs in. The FPGA here, otherwise known as Tiny Vicky, contains an instance of a, let me think, Texas Instruments 16750 UART driver. But it doesn't go ahead and implement any of the control lines like data terminal ready, carrier detect, clear to send, request to send, or any of those. It's really just simply send, receive, and ground. So if you've got a Junior and you haven't done anything with serial yet, you can wire it up with just 3 wires going to the header, to a DB9 in this case. You can make it to a DB25 if you like instead. And to that, I will wire in this, I'll say ubiquitous, but this Wi-Fi modem. And you'll see these lights here are kind of similar, or at least, you know, to the way that Hayes did it back then. And this is a Hayes compatible device. So I'm going to plug this onto my serial port here. I will provide USB power to here, and then I'll be up and online. And the next step here is going to configure the serial port through a basic program in SuperBASIC. Again, this is the 5-line, the 5-line terminal emulator. And this kind of goes back to some of the things that we did back in the 80s, which is cram as much as you can into each line of basic code. So you'll see it's kind of ugly. I reflect quite a bit on basic, SuperBASIC, and style of writing you know, programs in the old basics and what you can do in SuperBASIC. In a recent newsletter. I'll put a link to that below as well. But I have just one other thing to say about this setup I have here, which is pretty plain vanilla, right? I've got an SD card, no external drives, the DB9 going to the serial port on here. There's a strapping you'll need to do, which is a jumper that selects either the featherboard or the DB9, or rather the connection for DB9. It's called DB9, but you can wire it to a DB25, as I mentioned. I happen to have, you may see it here, a Commodore keyboard. So this is an original Commodore keyboard with different keycaps on it, connected up to the 20-pin connector on the, I'll call it the west side of the board, if this was oriented properly. And I'll talk about that probably in another episode. But this is a fun project as well, integrating this into that machine. There's really just one dip switch you need to select, plug it on, 20 pin, plugs right in, and it works. The kernel sees, microkernel rather, sees that the dip switch is down, or up rather. I think it's the 6th dip switch. And then the microkernel will read this keyboard, read the PS2 keyboard at the same time. You can type on both of them if you like. Anyway, that's a different discussion. So I'll plug in this modem and start sharing my screen. We'll get online in just a moment. Okay, so here we are at the at F256 Jr boot screen, and I'm running, which kernel is this one? I'm running kernel, looks like looks like October 15th, 2023 kernel. But this will work for all of them. This is a very early feature that was working as far as using the serial port. I'm going to load, let me think what it's called. Load, I think it's F term 5.base. Hope that's it. Yes, perfect. Okay, so it's complete. I'm going to turn the contrast up a bit so you can see it better. Hopefully that's better. And it's kind of crazy, the colors here in the listing, at least in this version of SuperBASIC. So there's the program, 5 lines, pretty densely packed. We'll go over it line by line in just a moment. But just to start with, I'm going to run this. It's going to sit there. There you go, F-term at the top, announcing that you're in a program called F-term. I'm going to plug this into here, turn this thing on, and you see a bunch of stuff go streaming across the screen. It says power, and I'm going to hit enter here. You can see the lights now. So you can see, oh, here it comes. So look at the screen. Yeah, a bunch of stuff connected. So it's got on there Hal's Friends, which is the name of the place I bought it from, I guess, the firmware that's on here. I'll include a listing of where you can buy your own. I think it's maybe 25 bucks at this point. These things were very, very popular a couple of years ago. Not as popular today. So I've got, I don't know, let's see, not much here. It's got, of course, my private address on there and the name of my my Wi-Fi. So I'm going to say AT, right, which is attention, and it says OK. Now I wonder, it's printing in black. I don't have room to change the color of this in my 5-line program, but I'm pressing. Here we go. That's a good one. AT. Okay. I press one of the function keys. Now all of the keys are being echoed and returned back from the modem, so to speak. So anything that's sent here, any control character, comes back to the display. Of course, it's printed through SuperBASIC to the regular print command. And if there's attributes in there that are, used by SuperBASIC to do things like move the cursor around, clear the screen, change the color of the screen, they'll all work. There's one feature to add here, which is a bell feature. I'll talk about that in a moment. But at least to start with, you can see I'm now connected to the modem. As I type something, you can see here, right, the character coming in and out. So it's coming into the modem through the, I guess, receive line and then sent back out to the modem. And this is, of course, the little antenna. Now, I type some gibberish, and I'll get back nothing. Now, if I do ATDT with a URL, this will connect me to where I want to go. So I'm going to quickly put this down, and I'll have a quick look to see the URL that I need. I don't want to type it wrong 17 times, so I'm going to pause the video. I'll be right back. Okay, so here I am at the F-term 5 prompt. There's not much here to see. All I had room for in this little program was to write the word F-term 5. Of course, the 5 stands for 5-line terminal. I'm going to press enter. I'm going to say AT, which says OK. Again, this is the Hayes command set. I'm going to say ATDT, let's see, CBBS dot MITS alterair.com colon 8080. Nope, 8800, sorry. There we go. Connecting. Okay, so here we are. This is the original, not the original, but this is what the original looked like. And if you look at the Byte magazine article, and I believe this is on archive.org, you'll see that it looks very much the same. A lot of the same options are here. Whoever's running this is not Ward Christensen, but whoever's running this took the original kind of code, software. It's running in some virtual instance someplace. But you can see, you know, basically the shape of it. So the first BBS, of course, was very primitive. And you can do, I guess, you can list the first time user information. So I'll say, do you want to list it? Yes, I do. Y, enter. And then it'll tell us, okay, what city are you calling from? This is optional. I'm going to skip out. I'm going to skip it. First name. File first time, last update. Sorry. First time file. The file was updated on, it looks like, July 14th, 2020. Want info on using a video terminal with CBBS? Yes, I do. Enter. Okay. I'm not going to read it to you, but I'll just let this stream to the screen, and you can see kind of an online view of what the functions look like and how it works. Purpose of the system, yes. You can pause it and read it if you like. But, you know, the point is that this is connecting it, I don't know, let's say maybe the hardware that makes up the system. This is running at maybe 1200 baud, I think. Quick sign what to do your first time, just kind of moving along here. There you go. So it's pretty responsive. This first BBS, of course, didn't have a lot of functionality. There was no games online, but the fact you can get online with a modem back in those days was really novel, and a lot of people were interested in this. You could leave message, of course. And this was, again, in the late 70s, I believe. And, of course, everything exploded from here. In 1982, the Commodore 64 was released. In 1983, I got my first 64. And I remember going over Lenny Weisberg's house and begging him to let me borrow his VIC modem. Now, the Commodore VIC modem was written about by, I don't know, tons of people about how successful it was. I'm just reaching for something while I speak here. And, you know, Commodore sold a pile of them. They did very well, I believe, in making deals with was it Prodigy at the time? CompuServe probably. And that they gave away so much software and temporary memberships with the VIC modem that it became an overnight success. So there's a story about how it was made in the contract that put the hardware together. Unfortunately, it was actually a pretty poor product. The quality control was poor. It didn't really, it had a very weak carrier, didn't work depending upon your phone system and your particular, you know, municipality. But this is the original manual that came with it. Pretty interesting. I'll put a link to this as well. Here's terminal software for the VIC-20. If you want to take a look at this compared to my 5-line terminal software. Of course, this is written out, and, you know, a bit easier to understand in terms of not cramming everything onto one line. This had some functionality built into it. I don't know if this has a C64 program either, but it would be similar. There's an explanation, some technology. VicTerm1 features what it can do. Anyway, you know, lots happened across the years. File transfers, of course, were a big use of this type of technology. I'm about to be, I hung up on already because I was jabbering away here. Connect time 3 minutes, so I didn't type quickly enough. This is very common. Many of the old BBSs had a single line, and if you didn't act and continue to respond, it would hang up on you for the next caller to call. So many of us didn't end up with a busy signal. I just want to point out now quickly that it kept track of how many characters I typed, how many characters it typed. So that's kind of a typical thing. I guess I didn't get too far as registering, so you really didn't get too much out of this quick look. But let me just quickly break this with the run stop key, of course. I'm going to change the contrast of the screen to maybe, how's this? Terrible. See, it's hard to tell on this. There we go, that's a good one. I'm going to clear the screen with a Control L, and I'm going to list. Now it's going to be in a kind of a obscure highlighting. I'm going to list the lines. List 10. Sorry. Okay. List 20. And list 50. Okay. So these are the lines that make up this terminal program. I'll tell you just briefly. The first two lines are nothing but setup. So I'm poking a 0 into memory location 1, which basically says I want the I/O to talk to the devices on the machine, versus screen memory versus character memory or color memory versus font memory. So that's poke 1, 0. You'll see this in a lot of super basic program. programs that access hardware directly, whether they're sprites or music, like a PSG, I was going to say, or the serial line in this case. So these pokes, 633, 630, 631, and 632, all have to do with the serial interface, the baud rate, polling mode, and a bunch of other things relating to the UART. I won't go through this, but I am going to link below a list, or rather a link to a newsletter I wrote that talks about MIDI, and it describes what each of these registers do in detail. Ultimately, when I get down to line 30, the first thing this does is it checks to see if any bytes are pending to be read. So this is checking for outside bytes coming into the box by checking to see if this bit of D635 is true. And if it is, then simply it says, well, incoming character equals a peak of D630. D630 is the send and receive address. And then if I have something, well, I'm going to go down to line 50. Otherwise, I don't. And that's the end of the if statement. And I'll jump down to line 40. In line 50, now assuming that a character came in, it's set to ICHAR. I have one feature. If ICHAR equals 7, which is a bell, otherwise known as a control G, I'm going to say ping, which does the super basic beep using the built-in PSG of a bell. Then I'll go back up to 30. If I don't have a bell, I'm going to print the character on the screen, which is here. It's a CHR dollar of the ASCII character value with a semicolon, so it stays on the line versus printing a new line. And then I'm going to go up to line 30. So that's kind of the top of this. If you get up to line 30 again, which is where I was checking the keyboard buffer, the incoming serial buffer to see if there's a character pending. If there's not, rather than going to line 50, I drop down to here, which simply checks if there's a key pending. So the O char, which is outgoing character, will be assigned from in key, which will basically check the keyboard. If there's something assigned, or if there's something not assigned, it goes back to 30, which is up here again. If there is something assigned, simply I poke it. I poke the character into the outgoing keyboard buffer. I don't have to print it to the screen because this modem is full duplex and it will turn that character around again. So the next time I go up to line 30, there'll be a character pending, which is the one I just typed. It'll jump down and dump it onto the screen on line 50, and then we'll be back kind of to start anew on line 30. So there you have a kind of a lightning fast explanation of the way this terminal emulator works. This is the 5-line FTerm5, a Foenix 5-line terminal. And that's about it for today. I just wanted to kind of run you through this. I spent some work playing with this stuff, and when I do finish something, a little tiny side project, I like to tell a bit about it and maybe put some links that may be interesting to you. If there's something else you'd like to see, please hit me up on the comments, and I'll be happy to kind of share more and show more. And that's all for today. We'll talk to you soon.